Okay. In order to find the absolute maximum minimum, today we're going to talk about just the last part of the notes. And again, we're trying to identify maximums and minimums in order to find absolute. So the key here is we were focusing before. Whoa. We were focusing earlier on local maximums and minimums. And in order to find those, we took the derivative and we set it equal to 0. Okay, because when you have a maximum or minimum, generally speaking, the derivative is going to be 0. Okay, if there is a local maximum, then for sure, and the derivative exists, then for sure the derivative is 0. Okay, so in order to find the absolute maximum minimum on the closed intervals, we should find something first. Okay, we should test or check endpoints. So a closed interval means that the graph doesn't go on forever. It doesn't go towards negative infinity, positive infinity. That you have this these endpoints, kind of like our very first graph right here. Okay, this is a closed interval where this would be your A value and this would be your B value. So we should check the endpoints. Meaning, in order to check the endpoints, all we really have to do is evaluate f of A and evaluate f of b. Okay? So when we check those endpoints, that will tell us how high or how low they really are. Second, we should find critical points. By taking the derivative and setting it equal to 0. And then third of all, plug those critical points back in to f of x. So this is just the way that we're going to be able to find exactly what our absolute maximum minimum are. So it's just finding the absolute maximum minimum of the given function over the intervals. We've got x squared minus 4x plus 3. Okay, so that's our function. Let's first test the endpoints. I have endpoints of 0 and 6. So how do we test to see what the function is at those spots? What do? Plug them in. F of 0 is 3. F of 6, 36 minus 24 plus 3, 15, right? So true or false? 3 is an absolute max. False. True or false? 15 could be an absolute max. True. What should we check first? Yeah, we've got to see where this derivative is equal to 0 and how low or how high it really goes. So let's try that. F prime of x is equal to what? 2x minus 4, so set that equal to 0, and x is equal to 2. So I know that at 2 it has a derivative of 0. That means I have what at 2? I have a critical point, and it's going to be a local max or a local min from what we know about parabolas, right? Does this parabola go up or down? It goes up. And so is this going to be a local max or a local min? Min. If a parabola goes up, it's got a minimum. So let's find out what that minimum value is. I take that point and plug it back into the original function. If I plugged it back into the derivative, what would I get? 0, because that's the slope there, and that's what we just figured out. So if we plug it back into the original function, we get 4 minus 8 plus 3 is negative 1. So I have 3 very interesting values here. 3, 15, and negative 1. Let's make a list right here, okay? Local min, local max. Global min, global max. What is the local minimum? -1. Does it have a local maximum? An endpoint doesn't count as a local minimum or maximum because you're at the end, and the definition of a local max or min is if you move to the left or the right, it's the biggest value or the smallest value around. And an endpoint, you really can't move to the side. Okay, what's the global min going to be? Yeah, it's the same as the local min in this situation. What's the global max going to be? 15. Just so you understand, I'd like to sketch just a really quick graph. We know that this graph has a local minimum at 2, and it goes down to -1. We already decided that f of 0 was 3. And we decided f of 6 was 15. Does everybody agree that the graph has this shape to it? It's a parabola, right? And it's on a closed interval, so we're just talking about part of it. So does that drawing fit with our answers? Yeah. So we should be able to identify the graph and be able to then verify that our solutions do match up graphically. Any questions how we did that? Pretty straightforward? Question? Excellent. So when I found where the derivative was equal to 0, which was 2, I plugged it back in and I got -1. So 2, -1. When I set the derivative equal to 0, I solved and I got 2. So 2 is my x value. -1 was my y value. Okay, let's do the same thing over here. Okay. Let's test our endpoints, f of -6. Oh boy. 2 times -6 to the third plus 3 times -6 squared minus 36 times -6 plus 4. -6 to the third is -216 times 2 is -432. Then you have -6 squared is 36 times 3 is 108. -6 times -36 is going to be positive 216 plus 4. So we'll add our positives together, huh? -432 plus 324, 328. Yeah. So that's going to be equal to -104. Anybody do that on your calculator? Okay. So -104 is the value for our endpoint. Okay. Let's try f of 3. We get 2 times 3 to the third. That's 3 times 3 squared. That's 36 times 3. That's 4. 8 times 2 is 16. 9 times 3 is 27. Oh, yes, thank you. 27 times 2, 54. Plus 9 times 3, 27. And it's 108 plus 4. This gives me 81. There's 85. That's 108. -23. There we go. We have two interesting values, negative 104 and negative 23. So that's what we come up with. So we've tested the endpoints. What should we do after that? Take the derivative and set it equal to 0. So let's just do that right away. 0 equals, what's the derivative? Very good. Take out a factor of 6. What are two numbers multiplied by negative 6? Add to 1. So negative 3, positive 2. Now I have to check those, right? So by this time, if you get tired of doing the arithmetic, you're afraid you're going to make a mistake. I do think that next year for my, not my calculus course, but for my pre-calculus course, I think that I will be having them do no calculators until the 4th test on logarithms. They didn't have it. Well, I think that would be good if we... Come on, open up. You concur, Larry? Oh, just running out of time. So if you plug in negative 3, you get 85. If you plug in 2, you get negative 40. Okay, so let's look at it. Which one of these is going to be the global max? Right? Yep. And then what's going to be the global min? These were endpoints, so can they be local maximins? No. So is oh, I'm sorry. The bottom two are endpoints. Negative 6 and 3 are endpoints, so they cannot be our local max mins. Is 85 could be a local max or local min? How can you tell? It's bigger than the negative 40. So yep, this is also a local max. And then, how about negative 40? Is that a local max or local min? Local min. Well, if we were to graph this, okay, so just to end here, so this is Elizabeth's question. She said, what about the local max and local min? That's what we did here, okay? So this is the point that we found. Positive 85, you can see it happens at negative 3. And positive 2, you can see that the value is negative 40. So you got to look at the graph. If you don't get something, you have to compare it to the graph and look and just, know that it's going to have that shape. We knew it was a cubic. We knew it generally had that shape. So, okay, you ready for the rest of your assignment? That will end chapter 4.1 for us. Somebody said 49, I believe. There you go.